Hi everyone. In today's class, we'll work out a numerical example on long fin.
In the previous class, we have seen the heat transfer through a long fin and the temperature difference along the length of the fin. The temperature difference for a long fin theta is given by theta 0 e raised to minus mx, where theta 0 is the temperature difference at the base of the fin, that is between the base surface from where the heat is transferred and the surrounding, the difference between the base temperature and the surrounding temperature. Whereas m is root of hp by kac. X is the distance where the temperature difference is required. So theta is the temperature difference at a distance x. And once you get the temperature difference, you can find out the temperature by adding atmospheric temperature. Since theta is T minus TA, you can find out T as theta plus TA. For a long fin, the heat transfer is given by KAC m theta 0, where K is the thermal conductivity, AC is the area of cross section, and m is the parameter which I have already explained, root of hp by kac, and theta 0 is the base temperature difference. Now we'll work out an example. It's a very long aluminum rod is connected to a wall at one end, while the other end protrudes into room air temperature at 25 degrees centigrade. The wall is at a temperature of 200 degrees centigrade. The rod is 5 mm in diameter and the heat transfer coefficient between the surface of the rod and the environment is 300 watts per meter square Kelvin. If the thermal conductivity of the rod is 150 watts per meter Kelvin, you need to calculate the heat dissipated by the rod. So it is already mentioned, it is a long aluminum rod. So you can directly apply a long fin formula to calculate the heat transfer. The problem itself defines it is a long fin. And the base temperature is given 200 degrees centigrade, ambient temperature is given 25 degrees centigrade, the rod diameter is given 5 mm, and the surrounding heat transfer coefficient is given as 300 watts per meter square Kelvin. Thermal conductivity of the metal rod is also given 150 watts per meter Kelvin. Now, these are the data given. I have written the data given. T0 is the base temperature and TA is the ambient temperature. Heat transfer coefficient is 300 watts per meter square Kelvin. Thermal conductivity of the aluminum rod is 150 watts per meter Kelvin. Diameter of the rod 5 mm means 0.005 meter divided by 1000, which will convert into meter. Now this is the base where the fin is connected. This is a fin in the form of a rod which is 5 mm diameter. Diameter is 5 mm. The base temperature is 200 degrees centigrade. 25 degrees centigrade is ambient temperature. Now the heat is flowing from the base through the rod and it is convected to the surrounding. Convection takes place because of the temperature difference. Because temperature here on the surface of the fin is 200, almost close to this base temperature. So 200 and ambient is 25. So there is a difference. And this difference in temperature causes heat to convect from the surface to the surrounding. As the conduction proceeds, the temperature drops and the temperature difference also drops, and when it comes to the end, the temperature difference decreases and the end part of the fin will not be efficient in convecting the heat. So for a long fin, the length, since the length is more, when it comes to the end, the temperature difference is 0. That is, the temperature becomes more or less 25 here, and ambient is also 25. 25 minus 25, the temperature difference will be 0. So this part of the fin, this surface of the fin is not dissipating any heat. So that is the idea of a long fin. Long fin, at the end, the temperature reduces to almost to ambient temperature. Okay. Now, this is how the heat is dissipated through a fin. Now, in this case, it is in the form of a circular rod. So you can find out the perimeter as pi d. Perimeter in this equation to calculate m, you need to use root of hp by kAc. P stands for perimeter of the rod, which is pi into d. AC is the area of cross section. Area of cross section, this is area of cross section of the fin, that is pi by 4 d square. So perimeter I have substituted pi d, area I have substituted area of cross section pi by 4 d square, and thermal conductivity is metal rod. It's already given. H is the heat transfer coefficient, that is it depends on the environment. Okay. So you have all this data to calculate M. So if you, before substituting the P and AC, I just reduce the formula to by substituting perimeter as pi d and the area as pi by 4 d square. And this is applicable only for circular cross section fins. So you get this d cancels and 1 pi cancels. 4 goes to the numerator. You get 4h by kd. So this formula is only for circular cross section. Rectangular cross section, you always go for this basic formula where perimeter will be 2 times width plus 2 times thickness, and the AC will be breadth into thickness. So that way you need to calculate. So this is always the formula which you have to use. In certain circumstances, you can reduce the formula into simplified form like this. Now you can substitute for H 300 and the diameter is 0.005, thermal conductivity is 150. If you substitute, you will get the M as 40. So this is a basic step where you need to calculate M, because all the heat transfer and the temperature difference, if you need to find out, you require M. So all of you understood this? Now let us go to the next slide where you calculate the heat transfer. So heat transfer for a long fin is given by kAc m theta 0. K thermal conductivity 150 watts per meter Kelvin. AC is pi by 4 d square, where d is the diameter 0.005, and m is we have calculated 40, and theta 0 is the base temperature difference, where base was at 200 degrees centigrade and surrounding was at 25 degrees centigrade. So at the base or at the root, the temperature difference existing between the base of the fin and ambient is 200 minus 25 or 175 degrees centigrade. So substituting this, you will get the Q as 20.617 watts. So 20.617 watts means 20.617 joules per second. Every second, 20.617 joules of heat will be dissipated through the rod. So this is how you find out the heat transfer. Here the length does not come because it is given that long fin and the length was not required to calculate the heat transfer. You can also find out the temperature at any point on the rod by using the equation theta is equal to theta 0 e raised to minus mx. That where x is going to be the distance at which you require the temperature difference. Once you get the temperature difference, you will be able to find out the temperature also. So some of the cases they may not state as long fin, but seeing the situation, seeing the length, thermal conductivity, all that, you should decide whether it is a long fin, short fin, or fin with the end insulated. So always short fin formula is going to be applicable in all the cases, and which we will discuss later. But long fin is an approximation. In certain situations, when fin length is more, you instead of going for a short fin formula, which is much bigger formula, you can go for a this approximation, that is the fin, end of the fin temperature difference is 0. In such case, quickly you can find out the heat transfer using this equation KACM theta 0. Okay, I hope all of you understood this.